Hey, my name is Alden Yellowhorse. For my ME363 class project, what I decided to do was develop an instrument that could measure temperature variation over a pond's depth. The reason I wanted to do this was to determine whether or not the surface of a pond in our area is warmer than its bottom. You can see this instrument in action now. The way this sensor works is that it uses a thermistor like you can see here on the end of this wire. And this thermistor, it's important because it changes its resistance with temperature. And what I can do with that is I can place it in a voltage divider circuit that you can see here, which allows me to measure the voltage across the thermistor. From that I can determine its resistance. From that resistance I can determine through an equation, a special equation, the temperature of the water around it. This is basically how this instrument works, and right now I'm going to explain how I built it. This is a diagram of the circuit that we're going to build. Here you can see the battery that will be provided by the data logger. Here you can see the resistor. Beneath it you can see the thermistor in its position in the circuit, and here you can see the sensor that will record the voltage across the thermistor. What you'll need is first a breadboard, a thermistor, and the details for exactly what kind are listed in the paper that'll accompany this video. You'll need about 4 or 5 1 to 2 inch strips of wire. You'll need a 10 kilo ohm resistor, a data logger. This particular type is a Logomatic V2 data logger, and again the information is on the paper. A twisty, a couple more twisties, sorry actually, a battery pack for the data logger, and a couple strips of electrical tape. The first thing you'll want to do is to take the data logger, and you'll want to insert an SD card that comes with the data logger kit. First of all, you'll want to take one of your strips of wire, and all these strips of wire, I've already done this, but I've stripped away the insulation from both ends. You'll want to leave a little bit exposed so that you can use them to make connections with. You'll want to take this first piece of wire, and there are holes here on this end of the data logger. You'll want to thread this end through the 3.3 volt terminal that you can see here. This will serve as the power source for the entire instrument. And you can solder this connection if you would like to, but it's not necessary. I'm just going to put the wire through and bend it to lock it into position. You'll want to take the second piece of wire, strip away again the insulation from both ends, and place one end in the hole right here labeled 1. This will be the sensor wire that will record the information in the electronic thermometer. You'll want to take the third piece of wire and insert one end into the ground terminal that you can see here. This will ground the entire instrument. At this point you'll want to place the entire board on the breadboard that you have. And now the first thing you'll want to do is take this first wire, the one that you inserted into the 3.3 volt power source, and you'll want to place that, reorient the data board by the way, so that the red strip is away from you. Take that first wire and place it in the red band of holes at the bottom of the board, or excuse me, at the top of the board. This will be the power source for everything that you're going to use here. Take the second wire and place this wire, this is the sensor, and that will go into the red band of holes at the bottom of the board, as here you can see. This last wire coming from the ground terminal, you'll want to place that in the blue band of holes at the bottom of the breadboard. Okay. Now you'll want to take the 10 kilo ohm resistor. Now one end of the resistor will need to go into the red banded holes at the top of the breadboard here. The other end will need to go into any one of the holes in this region. And any one is all right. Don't put it into any one of the banded holes at this end of the breadboard, just the holes in between. You'll want to take your last piece of wire, and I've cut this really short, it doesn't need to be. You'll want to place one end of this wire in the same row of holes as the near end of the resistor. The other end will need to go into the red band of holes on this end of the breadboard. Then, to make this part of the instrument fully functional, you'll just need to plug in the battery, and that will be simple. It will just go into this terminal here. Now, after making the handset, the next thing you're going to want to finish is to make the sensor itself. And this part is fairly simple. What you'll want to do first, and I've already done this, is I took two 20-foot long strips of insulated wire, and then every 1 foot or so, I taped them together with duct tape. So it's really simple. Just every 1 foot or so, connect them together so that you have a long strip of parallel cables. Strip away the insulation at both ends off of both of the wires. Take one end, it doesn't matter which, take one end, and your thermistor. Your thermistor is going to have two connections to it as well. You'll want to take one wire on the thermistor and one wire that you stripped here, and then you'll want to twist them together and form a connection. When you think you have a solid connection, you'll want to take some electrical tape and wrap the connection so that it doesn't come undone during your measurements. You'll want to repeat this procedure for the other connection. And the order in which you wrap these isn't important. The instrument will work either way. This one came undone, but alright, once you have these two connected, what you'll want to do next is bend them at their connections so that the thermistor bends back on itself like this. What you want to do at this point is take a plastic sandwich bag and place the connected end of this device in the sandwich bag. This will help keep water away from the connection, and it will also let this instrument float when you place it in the water, because we want this part of the thermistor to be in the water the whole time, and so we can help that happen by keeping this out of the water. Just wrap the bag around fairly well. And this is where you'll want to take one of your twisties and wrap it around one of the end. This is the lower end of the bag. Then you'll want to take the other twisty or another piece of wire, whatever you use isn't important, and wrap the top end of the bag. And after doing that, the instrument is complete. The only thing that you'll have to do to get it to function is to take the other end, the other two free ends that I was talking about. You'll need to strip the insulation away from these wires, and to place it in the instrument, you'll take one of them, which one is unimportant. just take one and place it in the red, one of the red banded holes here on the lower end of the breadboard. Then you'll take the other wire and place it in the blue band of holes on this end of on the same side of the breadboard. Once those two wires are connected, all you have to do is hit the on button on the data logger. It'll record the information that you want to and give you the temperatures that you need. This can be easily calculated as I've shown in my paper.